Okay, let's unpack this. Imagine you're cruising down the highway, feeling absolutely confident in your vehicle, maybe even a little luxurious in a high-end SUV. You're in control. The road feels smooth, and your car feels like an extension of your will. You're definitely not thinking about the hundreds of intricate components working together beneath you. And then you hear about a potential structural issue and a crucial hidden component, something you never even consider, yet it's absolutely vital for your safety and control, a core part of how your vehicle literally stays connected to its wheels. That's exactly what's happening with certain Range Rover Sport SUVs right now, and it's a fascinating, sometimes unnerving subject we're diving into today.
And this really matters to you, whether you're a Range Rover owner, maybe considering one, or even if you drive something completely different, because vehicle safety isn't just about crash test ratings, you know? It's about the fundamental integrity of every single component that keeps you safely on the road. Understanding how independent oversight from agencies like the National Highway Traffic Safety Administration, or NHTSA as we usually call it, operates is, well, it's crucial for all of us. They are effectively the public's vigilant guardian, almost like an engineering detective force, making sure that the vehicles we rely on every day meet and, crucially, maintain really stringent safety standards. Without that constant vigilance, our trust in automotive engineering could quickly erode.
Absolutely. So for this deep dive, the National Highway Traffic Safety Administration's Office of Defects Investigation, ODI, has opened what they call a preliminary evaluation into roughly 92,000 Range Rover Sport SUVs. That's a significant number of vehicles, and the implications are pretty substantial.
Right. So our mission today is really to pull back the curtain on this investigation, taking you beyond just the headline. We're going to break down the specific problem at the heart of this probe, what exactly is failing, and why it's so critical. We'll understand the full scope of the affected vehicles, getting into the nuances of why certain models are being targeted. We'll clarify NHTSA's, well, its multifaceted role in these types of investigations, walking through their pretty meticulous process. And crucially, we'll connect this specific case to the broader implications for the entire automotive industry, especially when we think about new materials, and most importantly, for you, the driver. We'll offer insights into what this means for your own vehicle choices and safety awareness. Our primary source for today's deep dive is a comprehensive automotive dive article titled NHTSA Launches Safety Probe of Range Rover Sport SUVs. It's a really well-researched piece that gives us the core facts we need to understand this complex situation thoroughly.
All right, let's jump right into the core of the problem then. The specific engineering detail that's caused all this attention. What exactly is under the microscope here?
Okay, so the NHTSA probe is zeroing in on the structural integrity of the front steering knuckle. And this came about after they received 12 vehicle owner questionnaires, or VOQs, alleging cracked front steering knuckles.
Right, the steering knuckle. That's a very specific, maybe even obscure part of the car for most drivers, isn't it?
It is indeed, yeah. And it's a critically important one that, you're right, most people probably don't think about unless something goes terribly wrong. To put it simply, just imagine your car's front wheel, how it turns when you navigate a corner, how it absorbs the shock of, say, a pothole, or how it maintains its alignment as you drive straight down the highway. The steering knuckle is essentially the pivotal component that makes all of that possible. It acts as the fundamental link. That's a good way to think of it. It rigidly connects your wheel hub assembly, where the tire and wheel bolt on, to the suspension system, specifically the control arms and ball joints, and ultimately it connects to the steering system too.
Okay, so it's like the central hub for all those front-end parts.
Exactly. Think of it as a complex load-bearing joint. Typically, it's a robust piece of metal, often a high-strength casting or forging. It's the part your wheel bolts to, and it's the conduit through which all the forces from the road bumps, braking, cornering are transmitted into the vehicle's structure. It's the point where your car pivots when you turn the steering wheel, and it also bears a huge amount of stress from braking forces, those road impacts, and just the sheer weight of the vehicle itself. So its structural integrity is absolutely foundational to maintaining control over your vehicle, allowing for precise steering and stable handling. Without a sound steering knuckle, the entire front suspension and steering geometry would simply, well, it would fall apart, literally.
So it's not just about turning. It's fundamental for the stability and the whole structural integrity of the front end.
Got it. Now, what are the specific details of where this alleged failure is happening, the crack itself? Precisely. If we think about it as that foundational joint, like we said, its integrity is paramount. If that joint fails, the system is compromised, you lose predictability, you lose control. The source, the article, specifically details where these alleged fractures are occurring, where the steering knuckle attaches to the upper control arm, which is secured using a pinch bolt. Now, this is a really highly loaded interface, a critical connection point that experiences significant stress during normal driving, cornering, braking, all the time, basically. And here's a key detail. These particular knuckles are made of aluminum.
Ah, aluminum. Not the old heavy cast iron you might expect.
Right. And aluminum is chosen for its lightweight properties, which is fantastic for things like improving fuel efficiency, reducing emissions, and enhancing performance because it lowers the vehicle's unsprung weight. That's the weight not supported by the suspension, like wheels, tires, brakes, and this knuckle. Lighter unsprung weight means the suspension can react faster to bumps, improving ride and handling.
Okay, makes sense. But aluminum, does it behave differently under stress compared to steel?
It does, and that's the crucial trade-off here. While aluminum offers these benefits, it behaves differently under stress and fatigue compared to traditional steel components. Aluminum alloys can be, let's say, more susceptible to certain types of cracks, particularly fatigue cracks that develop over time from repeated stress cycles, or maybe even stress corrosion cracking in certain environments, if not designed, manufactured, or surface treated absolutely perfectly. They also have what engineers call a finite fatigue life, meaning they can fundamentally only withstand a certain number of stress cycles before a crack might initiate. Steel, depending on the stress level, can sometimes have an infinite fatigue life. Plus, if there are any imperfections introduced during the casting or forging process, like tiny air bubbles called porosity, or small voids, or maybe inclusions of foreign material, or if the material's heat treatment isn't precisely controlled, these spots can act as stress concentrators. They become weak points where cracks can start much, much earlier than expected under normal loads. So, while it's a very desirable material for modern vehicle design, it demands incredibly rigorous engineering and, critically, quality control to ensure its long-term durability, especially in a component as absolutely critical as a steering knuckle.
That makes perfect sense. So if this aluminum steering knuckle cracks, particularly at that specific attachment point to the upper control arm, what are the alleged consequences when you're actually driving? What happens to the vehicle?
Well, the consequences, as NHTSA outlines them, are frankly quite severe and represent a significant safety risk. If the aluminum steering knuckle cracks in that specific area, the report states it can cause the upper control arm to detach while driving. Now, just try to visualize what that means for a moment. The upper control arm is a vital part of your car's suspension. It helps keep the wheel aligned vertically, it controls its up and down movement, and it maintains its proper position relative to the vehicle body. If that upper control arm detaches from the knuckle,
The wheel essentially loses one of its key connection points.
precisely. And that can lead to a loss of control that increases the risk of a crash. To use maybe a more tangible analogy, think of it like a key hinge suddenly failing on a really heavy door. The door doesn't just sag a bit, it likely swings wildly out of control or just collapses entirely. In a vehicle, this translates to an immediate and dramatic loss of steering precision and stability. The affected wheel could effectively lose its proper geometry, its alignment. This could potentially cause the vehicle to pull sharply to one side, become unresponsive to steering inputs, or in a really severe scenario, even cause the wheel to sort of collapse inwards into the wheel well. This would lead to an immediate and potentially catastrophic loss of control, especially if you're traveling at highway speeds. This kind of failure doesn't typically offer a gentle warning. It's likely a sudden event.
Wow, that sounds incredibly dangerous. Truly, the worst case scenario for sure. But I noticed the source. The article also included an important nuance about this preliminary evaluation, something that provides maybe a bit of immediate reassurance.
Yes, exactly. And this is a crucial point that helps put the investigation into perspective for you, the listener, and it really highlights NHTSA's proactive stance, which is important. Despite the serious potential consequences we've just discussed, the source explicitly states the NHTSA is also not aware of any injuries or accidents as a result of this condition. Quote. This is incredibly significant. It means this is a preliminary evaluation that is genuinely proactive, not reactive to a tragedy that's already happened. NHTSA isn't waiting for people to get hurt or for crashes to start piling up. They're acting on these early warning signs, those owner reports, to prevent potential incidents from occurring down the road. Their role isn't just about investigating past accidents, but actively working to prevent future ones. This underscores that the primary purpose of these investigations is prevention and ensuring safety before an accident happens. It's really a testament to the robust safety oversight system we have. It's acting like an early detection system, trying to catch potential widespread problems before they manifest in, catastrophic ways.
Okay, so prevention is key here. Now, here's where it gets really interesting, for me anyway, because these issues often come to light in surprising ways. The trigger for this whole probe wasn't some massive internal automaker study or, a class action lawsuit kicking things off, but rather 12 vehicle owner questionnaires, or VOQs. Just 12 individual reports out of potentially 92,000 vehicles. That feels like a tiny, tiny data point to launch such a large-scale investigation.
It absolutely does feel small on the surface, yeah. And what's truly fascinating here is the sheer power and the amplifying effect of consumer reporting in the safety system. It really raises an important question. How can a relatively small number of individual consumer reports, just 12 in this instance, representing a minuscule fraction, less than 0.015% of the potentially affected vehicle population, actually trigger a large-scale safety investigation? An investigation that could potentially impact and protect thousands, maybe tens of thousands, of other vehicle owners. It just underscores the incredible importance of reporting any anomalies, any unusual noises, unexpected vehicle behavior, or structural concerns you might notice to the appropriate authorities like NHTSA.
So those VOQs are like the first smoke signals.
Exactly. They are the initial crucial alarm bells. They are direct, unfiltered accounts from drivers experiencing these issues firsthand in the real world. Each VOQ provides NHTSA with vital early warning data points that suggest something might be systematically wrong, not just a one-off issue. NHTSA doesn't just see 12 isolated complaints. Their analysts see 12 data points that, when aggregated and carefully analyzed, might reveal a concerning pattern that warrants a deeper look. Their investigators are trained specifically to spot these kinds of patterns. They look for consistency in the reported symptoms, the vehicle models and years involved, and the specific component failures being described. Even a small number of very similar complaints, especially about a critical safety component like a steering knuckle, can strongly suggest an underlying systemic defect rather than just random wear and tear or, damage from hitting a curb.
Right, because 12 people reporting the exact same weird crack is statistically unlikely to be coincidence.
Precisely. Think about it. If 12 people took the time and effort to formally file a report about this specific, somewhat technical issue, how many more owners might be experiencing it but maybe haven't reported it yet? Or perhaps they haven't even noticed it, or they might have dismissed it as just a strange noise or something minor, or attributed it to something else. NHTSA operates on the principle that these early indicators, though potentially small in number, can absolutely be the tip of a much larger iceberg. They use statistical modeling, engineering judgment, and comparison with historical data to assess the probability and the potential severity of a wider issue based on these initial reports. It's really a testament to the system that individual citizen input, your input potentially, can initiate such a comprehensive and potentially impactful safety probe. Your vigilance as a vehicle owner directly contributes to the safety net for all road users.
So that really highlights the critical role of the individual consumer in this whole vehicle safety ecosystem.
Fascinating. Now that we understand the core problem, the cracked aluminum knuckle, let's talk about the scope. Which specific Range Rover Sports are we talking about here? It's not just any Range Rover Sport out there, is it?
That's correct. No. The probe is very specific, which again demonstrates the precision these investigations aim for. The source states it extends to 2014-2017 Range Rover Sport models manufactured by Jaguar Land Rover.
Yeah.
And to quantify that scale for you again, it impacts roughly 92,000 vehicles within those model years in the U.S. market. So if you own a Range Rover Sport, this is where you need to pay very close attention to your specific model year, because not all Range Rovers, not even all Range Rover Sports of that generation, are part of this preliminary evaluation. This targeted approach is really a hallmark of sophisticated defect investigations. They try not to cast too wide a net initially.
And the article mentions something called the L494 chassis. What exactly is a chassis in this context, and why is that detail important for understanding the scope of this investigation? That's a good question, and this is where the technical understanding gets a bit deeper, but it's important. The chassis is, in essence, the foundational platform upon which the entire vehicle is built. Think of it like the skeleton or the core structural frame of the car. It integrates key mechanical components like the suspension systems, the drivetrain engine, transmission, axles, and the steering system. The body shell, the part you see and sit in, is then mounted onto this chassis. For those familiar with Land Rover's engineering history, the L494 chassis designation represents a specific design and engineering generation for the Range Rover Sport. This generation marked a significant shift towards more advanced lightweight structures, using a lot more aluminum, precisely to improve performance, handling, and fuel efficiency. So, a chassis designation like L494 implies a common set of engineering specifications, shared components, and often similar manufacturing processes across all vehicles built on that particular platform during its production run. It tells us about the fundamental architecture of the vehicle.
Okay, so L494 means a certain underlying structure, mainly aluminum intensive.
Correct. Now, what's particularly interesting in the timeline here, as you pointed out, is that the source states the L494 chassis itself was produced over a longer period from 2013 through 2022. But then it immediately clarifies that not all models built on that chassis are included in the NHTSA's preliminary evaluation. Only the 2014-2017 model years are under scrutiny right now. This is where the real detective work begins for NHTSA and internally for Jaguar Land Rover. Why might only the specific years within that longer chassis production run be affected? This strongly suggests, as you alluded to, that it's unlikely to be a fundamental flaw inherent in the overall L494 chassis design itself. If it were, we would probably expect the entire production run, or at least a much broader range of model years, to be included in the probe.
Right, so it points to something more specific happening during those 4 years, 2014 to 2017.
Exactly. It points towards more granular variables, things that might have changed during just that period. For instance, there might have been a change in component suppliers for these aluminum steering knuckles specifically during those years. Perhaps Jaguar Land Rover switched to a different foundry or manufacturing plant for the knuckles in 2014 and maybe switched again after 2017. Or it could potentially be tied to specific batches of raw aluminum material that were used during that time frame. Maybe these batches had subtle metallurgical inconsistencies or didn't quite meet the required specs. Alternatively, there could have been slight design modifications or revisions made to the knuckle itself, perhaps minor changes to its geometry, its wall thickness in certain areas, or even the specific type of heat treatment applied to the aluminum. These changes might have occurred specifically within the 2014-2017 production window. Even seemingly minor design tweaks can sometimes inadvertently introduce stress concentrations or vulnerabilities that weren't anticipated.
Or maybe something on the production line itself.
That's another distinct possibility. Variations in the manufacturing process during those years. Perhaps a particular assembly line had issues, or a specific shift, or maybe there was a period where certain quality control parameters or inspection methods were slightly relaxed or not as rigorously enforced as they should have been. This could lead to a higher rate of imperfections slipping through, like those casting flaws we discussed earlier. Porosity, inclusions, or improper cooling rates during casting or forging. These subtle shifts in manufacturing consistency can introduce weaknesses that might only become apparent after several years of use and the accumulated stress cycles of driving.
So NHTSA has to dig really deep to figure out which of those possibilities, or maybe a combination, is the real root cause.
Absolutely. For NHTSA to narrow it down to these specific years already, it suggests they've likely started looking at internal OEM documents, supplier records, maybe design change logs, and production data provided by Jaguar Land Rover. They might eventually subpoena detailed material specifications, batch numbers for the aluminum, and quality assurance reports from both the manufacturer and its suppliers for those specific years. This level of precision is crucial. It helps pinpoint the exact problem, but it also aims to minimize the burden and anxiety on consumers and the manufacturer for vehicles that are genuinely not at risk. So if you own one of these specific Range Rover Sport models from 2014-2017, this detailed focus helps you understand why your vehicle might be potentially affected, while others built on the same L494 platform aren't currently part of the probe. It really is a testament to the rigorous, data-driven nature of these investigations, aiming to isolate the precise variables causing the potential defect.
That deep dive into the why behind just those specific years really makes the scope much clearer. It's not just random.
Right.
Okay, let's pull back now and look at the bigger picture of how agencies like NHTSA actually function. What exactly is the goal, the main purpose of a preliminary evaluation like this one? What are they trying to achieve in this initial phase, and what steps do they typically take?
Right. The purpose of a preliminary evaluation, or PE, is clearly defined in the source article, and it's really a foundational step in NHTSA's process for ensuring vehicle safety. Its stated purpose is to determine the scope, severity, and root cause of the condition. Let's break that down a bit into what it actually entails in practice.
Okay, scope, severity, and root cause. Let's start with scope.
Okay, scope. This means they want to understand not just how many vehicles might be affected, that initial 92,000 estimate might be refined, but also where these vehicles are geographically located, how they're typically being used, for e.g. off-road versus highway, and importantly, if any environmental factors like climate extremes or road salt usage seem to play a role in the cracking. Is the problem truly limited to just these 92,000 Range Rover Sport SUVs from 1417? Or could similar aluminum knuckles, perhaps from the same supplier or using the same process, have been used in other Jaguar Land Rover models or even different model years? To determine this, they'll analyze warranty claims data from the manufacturer, field reports from dealerships, maybe reports from independent mechanics, and of course they'll keep collecting and analyzing those crucial vehicle owner questionnaires.
Okay, so scope is about defining the boundaries of the problem. What about severity?
Severity refers to assessing just how dangerous the condition is if it actually occurs. How likely is this specific type of crack at that specific location on the knuckle to progress to a complete detachment of the upper control arm? How sudden is the potential failure? Does it typically provide any warning signs to the driver beforehand, maybe unusual noises, steering changes, or vibrations? Or is it likely to be an abrupt, no warning failure? And critically, what is the potential for a crash or injury resulting from this failure mode, even though thankfully none have been reported yet? This involves detailed engineering analysis, risk assessment modeling, and looking at the kinematics of the suspension if that connection fails.
And finally, the big one, root cause.
Yes, root cause. This is perhaps the most critical and often the most challenging part of the investigation. What exactly is causing these specific aluminum steering knuckles to crack in that particular location? Is it a flaw in the material itself, like an improper aluminum alloy composition or inconsistent material properties? Is it a fundamental design flaw? Maybe the shape creates unintended stress concentrations under load? Is it a specific manufacturing defect, those casting imperfections, porosity, or maybe issues with the heat treatment process? Or could it even be related to maintenance practices or unusual usage patterns, although that seems less likely given the specific nature of the alleged cracks? This is the core investigative phase where NHTSA engineers and technical experts meticulously gather and analyze data and physical evidence.
What kind of evidence do they look at?
Well, this could involve physically inspecting failed components retrieved from vehicles, perhaps conducting detailed metallurgical analysis in a lab to examine the material structure and the fracture surfaces under powerful microscopes. They might perform computer simulations, like finite element analysis, FEA, to model how forces and stresses act on the knuckle during driving. They could even conduct destructive testing on sample knuckles, trying to replicate the failure mode under controlled laboratory conditions. And, very importantly, they'll request vast amounts of data directly from Jaguar Land Rover. This includes things like original design specifications, detailed manufacturing process documentation, quality control records and pass-fail rates, supplier information and audits, and any internal testing data the company might have related to the knuckle's durability. This whole meticulous data gathering and analysis process is what allows NHTSA to move from those initial anecdotal owner reports to a scientifically supported conclusion about the defect. It's a very methodical, data-driven process, and it often stretches over several months before they decide whether to close the PE or escalate it to the next stage, which could lead towards a recall decision.
Okay, so once they've hopefully gone through this rigorous preliminary evaluation and determined the scope, severity, and the likely root cause, what's the path to an actual recall? Does NHTSA just automatically order it then? Or are there other ways this process unfolds? It sounds like there might be a bit of a delicate dance between the regulator and the manufacturer.
You've absolutely hit on a critical point there about the interplay between them. It's not always confrontational. The source article outlines two primary paths to a recall, and this illustrates that dynamic relationship quite well. It states, although vehicle manufacturers can initiate many safety recalls, others may be influenced by the outcome of NHTSA investigations, or may be ordered by the agency for more serious safety concerns. So let's break that down. Often, manufacturers will proactively initiate safety recalls themselves. They might discover a defect through their own internal durability testing, analysis of warranty data showing a spike in certain repairs, or reports from their dealer network. In many cases, it's in the manufacturer's best interest financially and reputationally to manage the recall voluntarily, get ahead of the issue, and demonstrate responsibility to their customers and to NHTSA.
But NHTSA can also push for it.
Right, yes. If NHTSA's investigation, especially if it moves beyond the preliminary evaluation PE stage into a more formal and intensive engineering analysis, EA, uncovers what they determine to be a significant safety-related defect, they gain considerable leverage. At this point, they can either strongly influence the manufacturer to conduct a recall, Essentially, they present their findings, the data, the engineering analysis, the risk assessment, often overwhelming evidence in such a way that the manufacturer agrees it's necessary to act and initiate a voluntary recall under NHTSA's oversight. Or in cases where the manufacturer might be reluctant to recall, perhaps disputing the findings, or if the safety concern is deemed particularly severe and immediate, NHTSA has the authority to directly order a mandatory recall. This demonstrates NHTSA's considerable regulatory power and its role as the ultimate arbiter of vehicle safety in the U.S. market. They can impose substantial fines and other legal penalties if a manufacturer fails to comply with safety regulations or acts too slowly on a known defect.
And does NHTSA's job end once a recall is announced?
No, not at all. And that's a critical point that's often overlooked by the public. Their role includes ongoing oversight after a recall is issued. The source notes that the NHTSA is also responsible for monitoring an OEM's corrective action to ensure successful completion of any recall campaign. This isn't a one-and-done deal where NHTSA just identifies a problem and then walks away, leaving it to the manufacturer. No, they actively oversee the fix itself. They review and approve the manufacturer's proposed remedy, whether it's a software update, replacing a faulty component like the steering knuckle, or maybe even a design modification. They need to be satisfied that the fix is adequate, effective, and will actually resolve the underlying safety issue reliably. Then they monitor the recall completion rates. They track how many of the affected vehicles are actually getting repaired. They want to see high completion rates, ensuring that the safety risk is being effectively mitigated across the vehicle fleet. This often involves tracking parts availability for the repair, dealership capacity to perform the recall work, and the effectiveness of the manufacturer's public outreach efforts to notify owners. If a recall isn't progressing well, maybe parts are slow to arrive, or owners aren't bringing their cars in, NHTSA can step in again and push the manufacturer to improve the campaign's execution.
Wow, so it's a cradle-to-grave responsibility almost, from defect identification right through to confirming the fix works and gets done.
Exactly. If we connect this whole process to the bigger picture, it really highlights the critical balance that exists between the manufacturer's responsibility, which is fundamentally to design, engineer, and produce safe vehicles, and the regulatory oversight provided by agencies like NHTSA, which acts as that crucial check and balance on behalf of the public. NHTSA functions as a guardian of consumer safety, continuously pushing manufacturers through investigations and the threat of enforcement to uphold the highest safety standards. Without this kind of independent, data-driven, and authoritative oversight, public trust in vehicle safety could be severely undermined, and frankly, our roads could be a far more dangerous place. This entire process, from those initial 12 owner reports potentially leading all the way to recall oversight, is a complex but vital testament to the layers of protection built into our modern automotive ecosystem.
Okay, that context on NHTSA's role is really helpful. So what does all of this mean for the broader automotive landscape? Is this Range Rover problem, this potential knuckle issue, just a unique anomaly, something specific to JLR? Or does it maybe fit into a larger pattern we're seeing in the automotive industry, especially when we consider suspension issues or component failures? The article offered some really valuable context by mentioning other recent recalls that caught my eye.
That's an excellent question, and you're right. The article does provide some very insightful parallels that suggest this isn't necessarily happening in a vacuum. This Range Rover probe doesn't seem to be an entirely isolated incident. It definitely resonates with other recent safety concerns that have popped up in the industry, perhaps suggesting broader trends or shared engineering challenges manufacturers are facing. For example, the source highlights a parallel with the Ford F-150 Lightning electric pickup trucks. It states, in May, Ford Motor Company recalled over 29,000 F-150 Lightning pickups for a similar front suspension concern.
Similar. How was it also cracking knuckles?
Well, let's dig into the specifics of that Ford Lightning issue because this is where it gets interesting. While the potential outcome was alarmingly similar, involving a potential detachment in the front suspension, the reported root cause was quite different. The Ford Lightning recall was apparently due to an improperly torqued nut for the ball joint which secures the front upper control arm to the knuckle assembly. This nut may come loose and cause the upper control arm to detach. So in Ford's case with the Lightning, it wasn't reported as a material crack in the knuckle casting itself, like the allegation in the Range Rover probe. Instead, it was described as a manufacturing or assembly error related to a fastener specifically. That crucial nut wasn't tightened correctly to the required specification during assembly, or perhaps it had a tendency to work itself loose over time due to vibration or other factors. This really highlights that even seemingly simple manufacturing steps, like tightening a nut, if not executed with absolute precision and followed up with rigorous quality control checks, can potentially have catastrophic safety outcomes down the line.
So different cause, bad torque versus potential crack, but the same dangerous result. Upper arm detachment.
Exactly. Despite the different root causes, the potential consequence is eerily similar. A critical component in the front suspension, specifically the upper control arm, detaching from the steering knuckle, leading to a sudden loss of vehicle control. This similarity underscores that the connection point between the control arm and the knuckle is a highly vulnerable and absolutely critical interface in vehicle suspension design, regardless of the manufacturer or vehicle type. It's a common point of potential failure if anything goes wrong, whether it's a fastener torque issue, a flaw in the design geometry, or a failure in the material itself. It tells us that engineers across the industry are constantly wrestling with balancing complex forces, material properties, and assembly processes at these critical joints.
And there was another Ford recall mentioned in the article that seems even more directly comparable to the Range Rover issue, also involving aluminum knuckles, wasn't there?
Yes, absolutely. And this one is a particularly poignant parallel, I think. The article also mentions that Ford also recalled 4,600 model year 2024 Mustangs last summer for rear aluminum suspension knuckle casting imperfections that may lead to fractures and increase the risk of a crash.
Okay, now that sounds almost identical. Aluminum knuckles, casting imperfections, fractures.
Precisely. This Mustang example is remarkably relevant because it explicitly involves aluminum suspension knuckle casting imperfections, leading directly to fractures. A direct, almost mirror image scenario to the allegations surrounding the Range Rover's aluminum steering knuckle potentially cracking due to, presumably, some underlying flaw.
So what's fascinating here is we're seeing this recurring theme involving aluminum suspension components and unexpected fractures popping up in different parts of the suspension system, front knuckles on the Range Rover, rear knuckles on the Mustang, and across different manufacturers, Ford and Jaguar Land Rover.
Exactly. And this raises a crucial and I think really important question for the entire automotive industry moving forward. Are these truly just isolated, unrelated incidents? Or does the increasing reliance on advanced, lightweight materials like aluminum in critical structural components driven by fuel economy and performance goals, coupled with ever more complex manufacturing processes like casting these intricate shapes, present new and evolving challenges? Challenges related to quality control, ensuring long-term durability that perhaps OEMs, manufacturers, are still grappling with.
Can you elaborate on those casting imperfections mentioned for the Mustang? What does that actually mean?
Sure. Casting is a very common manufacturing process for creating complex metal shapes like suspension knuckles. Basically, you pour molten metal, in this case aluminum alloy, into a precisely shaped mold and let it solidify. However, imperfections can arise during this process due to various issues. You might get porosity, which are tiny air bubbles or gas pockets trapped within the metal as it cools. You could have inclusions, which are small particles of foreign material, maybe bits of the mold or oxides embedded in the metal. There are things like cold shuts, which occur when two streams of molten metal flowing into the mold don't properly fuse together, creating a weak seam. Or you might get shrinkage cracks if different parts of the casting cool and solidify at uneven rates, creating internal stresses. These flaws, especially if they're internal and not easily visible on the surface, can act as significant stress concentrators. They create weak points that drastically reduce the component's fatigue life, making it much more prone to initiating and propagating a fracture under the normal stresses of driving.
And presumably finding these tiny internal flaws is hard.
It can be very challenging, yes. Detecting these internal casting flaws reliably often requires advanced non-destructive testing methods, like industrial X-ray inspection or ultrasonic testing, which can scan through the metal. These techniques add complexity, time, and significant cost to the manufacturing process, especially if you need to inspect 100% of safety-critical parts.
So the push for lightweighting with aluminum is great for efficiency and performance.
Absolutely. The benefits are real. Weight reduction is key. But it simultaneously introduces this new set of complex engineering and manufacturing considerations. As we discussed, aluminum alloys have different fatigue characteristics than traditional steels. They can be more sensitive to those stress concentrations from imperfections or sharp design features. And their failure modes can sometimes be less ductile, meaning they might fracture more suddenly, with less warning or deformation if not designed, alloyed, and produced absolutely correctly. This means that manufacturing tolerances have to be incredibly tight, process controls must be strictly maintained, and quality assurance processes, including that non-destructive testing, need to be absolutely foolproof for these critical parts. These incidents we're seeing across different brands and components perhaps suggest that manufacturers are still potentially refining their mastery over mass producing these advanced materials consistently and ensuring their long-term durability under the widely varying conditions of real-world vehicle use. It implies that sometimes the true long-term durability only becomes fully apparent years after the vehicles are out on the road, accumulating miles and stress cycles. It's really a continuous learning curve for the entire industry as materials science evolves.
And NHTSA is watching all of this, right? Not just Knuckles.
Oh, absolutely. And just to emphasize NHTSA's broad reach and ongoing vigilance across the board, the article also briefly cites other recent NHTSA probes mentioned in its related reading section. For example, they're investigating reports of sudden, unexpected downshifts in Ford F-150s that sounds like a potential software or transmission control module issue. They're also looking closely into Ford's Blue Cruise Advanced Driver Assist System, ADS, that involves highly complex software, sensor integration, and human-machine interface concerns. They even recently fined Ford for being too slow in responding to a previous safety recall, which highlights their role in compliance enforcement, making sure manufacturers act promptly on known safety issues. So this Range Rover Knuckle probe isn't happening in isolation. It demonstrates NHTSA's comprehensive and ongoing oversight across a vast array of potential vehicle defects. They're looking at everything from fundamental mechanical issues like a steering knuckle or a transmission problem to sophisticated software concerns and engine management or ADAS features, all the way to ensuring manufacturers comply with the procedural rules about how quickly and effectively recalls must be executed. Their scope is incredibly broad, continuously monitoring, investigating, and reacting to potential safety hazards across the entire and increasingly complex modern automotive ecosystem. It's really a full-spectrum approach to ensuring vehicle safety for all of us.
That really paints a comprehensive picture, showing how this specific Range Rover probe fits into a much larger context of automotive challenges and regulatory oversight. So to kind of bring it all together for you, the listener, let's briefly summarize the key takeaways from this deep dive today. We've explored the specific Range Rover Sport steering knuckle issue, the potential for cracks in these aluminum components. We've delved into NHTSA's meticulous investigation process, starting with just a few owner reports and potentially leading to a major recall. And we've connected this particular probe to broader trends in automotive safety, specifically the ongoing challenges and implications of incorporating advanced lightweight materials like aluminum into critical vehicle structures.
And why should you, the listener, care about all this, especially if you don't happen to drive one of these specific 2014, 2017 Range Rover Sports? Well, understanding these investigations gives you crucial insight into the many, many layers of safety that are built into modern vehicles. It's not just about those crash test star ratings you see advertised. It's also about the fundamental integrity of every material chosen, every design decision made, every manufacturing process implemented, and crucially, the vigilant oversight of regulatory bodies like NHTSA acting as a safety net. It highlights that vehicle safety is definitely not a static achievement, not just a checkbox ticked off once a vehicle design is finalized or leaves the factory floor. Instead, it's an ongoing, dynamic process, a continuous feedback loop involving design, rigorous testing, real-world performance monitoring through data and owner reports, and the constant vigilance required from both the manufacturers who build the cars and the regulators who oversee them. It's really a testament to the fact that even with incredibly advanced engineering and cutting-edge materials, the unexpected can still happen. Flaws can emerge. But a sophisticated system is in place, designed to catch these issues, hopefully early, and work systematically towards a resolution to protect the public. Ultimately, it empowers you with the knowledge that your vehicle safety is a shared responsibility involving the engineers, the manufacturers, the suppliers, the regulators, and even you, the consumer, who can act as a vital part of that early warning system by reporting potential issues.
And this all raises an important final question, something for you to perhaps mull over after this deep dive, especially given this accelerating trend towards using lightweight materials like aluminum alloys throughout modern vehicles. A trend driven by the persistent need to improve fuel efficiency, reduce emissions, and enhance performance. Considering the instances of fractures and casting imperfections we've discussed today in both Range Rover Sports and Ford Mustangs, affecting critical suspension components, how might we as consumers, or even professional vehicle inspectors and mechanics, need to adapt our understanding of vehicle longevity and potential points of failure in the future? Should we perhaps be looking beyond just the traditional warning signs and expected wear and tear patterns we associate with older, predominantly steel components? What new questions should you, as a current or future vehicle owner, maybe start asking? Questions about the specific materials used in your vehicle's critical structural and suspension components, and how those material choices might affect its long-term durability, its future maintenance requirements, and its overall safety profile as it ages in this new era of automotive materials. It's clearly a new era of automotive engineering, and with it come new considerations for all of us about what constitutes long-term reliability and safety out there on the road.